Okay, students, we're going to talk about lesson 3.8, where we're talking about logic. Now, you may remember we're using this text right here, and we've talked about several of these lessons, beginning with the basic statements down here to 3.8, arguments and Euler diagrams. Your author made a good point of pointing out his appreciation of Mr. Leonhard Euler, a great mathematician. And I really like what he pointed out here about the last 17 years of his life. He produced a lot of work. So I always take that as a form of encouragement to push on, even though things are not perfect. Anyway, in this lesson, arguments and Euler diagrams, actually, this is sort of a revisited version of Aristotelian logic or categorical logic, where we reason in classes. And the human mind can class things into different categories. And this is a really helpful way to reason. It was pretty dominant in the history of logic. Anyway, so for this objective, we're going to use Euler diagrams to determine the validity of an argument. And so you could consider this categorical reasoning in a sense. Okay, now we're going to use for our backdrop what we learned in set theory. Remember, we talked about the subset, we talked about disjoint, we talked about sum A or B, or we talked about intersecting sets. So if you notice here, we've already referred to this. Here, all A are B, here, no A or B, some A are B, and some A are not. Notice the little dot that's representing at least one item. So keep that in mind. Now, so here's like the little procedure, and this will work. It'll take a little time. We'll do a couple of examples, and I'll try to make a video where I go through some of the homework problems. So number one, you need to make an Euler diagram for the first premise. So start out with the first, make an Euler diagram for the second premise on top of the first. Now you could do that on one diagram, or you may want to make two separate diagrams, depending upon how that works out. And step number three is the most important one. The argument is valid if and only if every possible diagram illustrates the conclusion of the argument. So if there's one possible diagram that does not, then that means that the conclusion's not true in every case, therefore it's invalid. So bottom line is you want to have an airtight case. And if you have air coming out of your spaceship, you're in trouble. Okay? So you will die, and then your argument will die. It's just not that rock solid. So keep that in mind. All right, so here's an example. All people who arrive late cannot perform. Think about it, band. All people who arrive late cannot perform. All people who cannot perform are ineligible for scholarships. Now notice the all in the all. We have two categories, people, and then we have cannot perform. Then we have people who cannot perform are ineligible for scholarships. All right, so here's the conclusion. Therefore, all people who arrive late are ineligible for scholarships. Does that make sense? That's a good question. All right, well, we're going to make an Euler diagram for the first. All people who arrive late cannot perform. And we're going to make an Euler diagram for the second. Look, all people who cannot perform are ineligible for scholarships. What does that say for the all people arriving late and the ineligible for scholarships? Does that bolster the case? Does it visually show that all people who arrive late are ineligible for scholarships? And the answer to that is yes, so that's really, really neat. All right, here's another one. All poets appreciate language. All writers appreciate language. Therefore, all poets are writers. Okay, now you probably have a kind of an opinion about that there may be a problem with that. So again, first one, all poets appreciate language. Let's look at that. All poets, here this circle, appreciate language. That's this circle. How many poets are in the circle of people who appreciate language? All of them. That makes sense. Now, all writers appreciate language. All writers. Could I put the writer circle here? Yes. Could I put the writer circle here? Yes. Could I put the writer circle here? Or could I put the writer circle here? So there's more than one possibility. Can I conclude, okay, again, can I conclude that all poets are writers? Can I conclude in each of these that all poets are writers? Well, here I have none, some, all, and this is just backwards. So there's many possibilities here, and not all of them verify the conclusion. Therefore, we say the argument is invalid. So keep that in mind. All right, now it gets a little tricky when you use the word some. So here's some points I want to make. Let's take this argument right here. All people are mortal. Here's people, here's mortal. Some mortals are students. Some mortals are students. Okay. Now here in this particular diagram, I have students right here, and I have a black dot representing some mortals. Now the question is this black dot representing some mortals that are students? And of course the answer is yes. Now notice the conclusion. Therefore, some people are students. Some people are students. Now wait a minute. Now this is showing no people are students. Of course that doesn't make sense to us here, but according to the way we're looking at the argument, you cannot say that some people are students. So this is a diagram that does not verify the information in the argument, and we call that our little Einstein bagel example from chapter 1. We call this a counter example. So hopefully that helps you out. Again, so let me say the dot in the region of intersection right here shows that at least one mortal is a student. But the diagram does not show that the people in the student circle intersect. So those two don't intersect, and because they don't, then there could be no people that are students. So it's only valid if for every possible diagram the conclusion of the argument is shown. Again, the conclusion, some people are students. The diagram does not show the people circle and the student circle intersecting with the dot in the region of the intersection. Conclusion does not follow from the premises, therefore the argument is invalid. So keep these thoughts in mind as you're working the problems here, and hopefully that'll help you out.